Okay, unfortunately I didn't record over this, so the first thing we should talk about is learning and what it is. And it's results in a change in an organism's behavior that is often, I wouldn't call it permanent, but it's a response to a stimulus that an organism has to be experience and remember and uses an association, which then starts a certain response. Learning is a lot more flexible, obviously, than a fixed action pattern. A fixed action pattern, now, both things can be simple or complex. There are fixed action patterns that are very complex in terms of the neurology and the nervous system response behind it. The same thing can be said of learning. I mean, classical conditioning. You don't have to be a genius to be conditioned. There are all kinds of animals that are really simple animals that you can apply classical conditioning to. Normally, we learn by association. We experience one thing, and then something else, and we see there's an association between them, maybe a cause and effect. This kind of association, well, Aristotle suggested it, and then during the English and Scottish Enlightenment, Locke and Hume. Basically, we learn one stimulus and associate it with another. In this case, it's not really nice, but we have a sea snail that associates a splash with a tail shock. That's really pretty mean, I think. Result after repetition, we see lightning. Plus stimulus 2 is thunder. And then when we see lightning, we usually anticipate a big bang later on. So here's a kind of a sequence. Response to a balancing ball. If he does it right, he gets food and the behavior is strengthened. The better he does it, the more food he gets. Okay, pushing a vending machine button, you receive a candy bar. Of course, it's going to cost you in this case. So Pavlov was really the first to elucidate it and then to do actual experiments on it to show that it actually happened. Later on, this is all psychology stuff. So the last time when we were talking about history of behavior, most of this was going on in the United States, whether it was with dogs or rats or whatever. Limited number of species, but actual learning behavior and different types of learning. So there's a couple of different things going on here. There's something called the unconditioned stimulus that happens automatically. Let's say it's lightning. the natural unconditioned response, for example, well, we'll talk about food, is you smell or see the food, you start salivating. Okay. In classical conditioning, you also, there's unconditioned stimulus, unconditioned response, and then conditioned stimulus and a conditioned response. So originally, you have a neutral stimulus that after association, well, without an association, a dog hears a bell and nothing happens. But if you start to associate it with the unconditioned stimulus, then you have an association with the unconditioned stimulus, and it comes to trigger the conditioned response, which is now the dog is salivating with the bell. Not because of seeing the food or smelling the food or tasting the food, just because of the bell. So here's basically Pavlov's experiment. You have the unconditioned stimulus. Let's say the dog sees it or smells it, salivates. You have the neutral stimulus, which is, in fact, the bell. So that's the conditioned stimulus. And then hold on, let's see here. Right. And then here we are. The neutral stimulus and the unconditioned stimulus, namely the food, are paired together, triggers salivation. There's an acquisition phase. And in a lot of cases, it gets better and better. The response gets better and better and more closely associated with each other as time goes on. Usually, the neutral stimulus needs to come before the unconditioned. So you ring the bell, they get a whiff of the food, and then there's not much time between one and the other. Now we can see graphically, there's also, you can actually lose a conditioned stimulus and conditioned response. So you do it, but then you don't do it again for months. The actual, or years, whatever it is, there's a certain point where you acquire the conditioned stimulus and the unconditioned stimulus over time, but if you don't do it again, then you get what's called an extinction curve. Depends on what it is, and it depends obviously on the organism. Some organisms have tremendous memories, and so the extinction curve may not ever really go away. And then in terms of the y-axis, of course, depending on how weak the signal or how long the signal actually is. So, when can you get a recovery of the association? So after a rest period and extinguished condition response, spontaneously recovers if you pair the CS and US again. But if the CS persists alone, the CR becomes extinct again. In other words, there's a loss between the tone and then the salivation. And then again, let's see, right. Spontaneous recovery, of the CR. These are the conditioned response. That's salivation. But the stimulus alone, just by not reinforcing that association, then it no longer causes the individual to salivate. Yeah.
So the unconditioned stimulus of the food unconditioned response is salivating?
Yes.
And is there any way that you can take away the unconditioned response? Or is that just kind of instinctual? There's no way to, in his experiments, that you can take away something?
I guess, I don't know. What do you guys think? So the unconditioned stimulus normally in let's say the food business, there's some cue that there's food there. Might be a visual cue, might be a smell, might be a sound, like popcorn, something like that. Do you think you could actually just have the bell and where the popping, you hear popcorn, or let's say no, you smell a smell and you no longer respond to it? I don't know. Yeah?
Could you condition the response for that and then take the theory of the conditioning, which associate that with something negative?
Oh, that's right. Absolutely. That's a good example. Right. So you could actually then associate it with a second conditional stimulus. So let's say with, like, they do this a lot with people getting treated for alcohol. Okay. They see a shot glass. Someone pours it in, they want to drink, they drink it. But then you they take this drug that makes them nauseous every time they have a glass of, let's say, vodka. And so over time, the sight of a glass with vodka in it makes them sick. In fact, we're going to look at a little video. In fact, right now, let's see here. So a stimulus generalization is a tendency to respond to a stimuli similar to the conditioned stimulus, unless, let's say, the tone, but you can generalize it to other things. So this is called a generalization. Pavlov's conditioned the dog's salivation, that's conditioned response, by using, instead of the tone, miniature vibrators on the thigh. When he subsequently stimulated other parts of the body, the salivation dropped. Stimulus discrimination. Animals can actually distinguish, obviously, between certain stimuli, even things that are somewhat similar. So, for example, you can get the dog to actually salivate at 256 cycles per second versus 392 cycles per second. You get no salivation. In fact, animals, in addition, have kind of a filter so that they actually pay attention to the things that are important, but we'll get to that a little bit later. In extending Pavlov's understanding, Pavlov and Watson considered consciousness, or the mind, unfit for the scientific study of psychology. In other words, kind of making inferences about what's going on in an animal's mind or nervous system. However, they underestimated the importance of cognitive processes and biological constraints. Now, early behaviorists believe that learned behaviors of various animals could be reduced to mindless mechanisms. This is actually kind of like a FAP, fixed action pattern. You don't have to think about it. It's just the right stimulus, it goes into action. But later behaviorists suggested that animals learn the predictability of a stimulus, meaning that they learn expectancy or awareness of a stimulus. Also, animals have predispositions for learning certain things and not others. In class today, we talked about, I asked, what's a good biological predisposition? And one of the students said, learning language. Now, Pavlov and Watson believed that laws of learning were similar for all animals. Therefore, a pigeon and a person do not differ in their learning, but that's clearly crazy. However, behaviorists later suggest that learning is constrained by an animal's biology. Exactly. Species-specific defense reactions. Obviously, an animal that, let's say, learns to walk cannot learn to fly because it doesn't have wings, it has legs. So there's a different kind of behavior there, constrained basically on the phenotype of the animal. Depending also on the kind of environment an animal lives in, if it lives in a really safe environment, like you often see on oceanic islands that are isolated, a lot of the animals appear almost tame. There are no real predators for them, like the Hawaiian Islands. There were no predators. There's some hawks, but there are no real predators until humans came along and introduced rats and things like that. And so, in addition to predispositions, there can be a lack of predispositions. If you have a population of elk that have been grew up in the presence of wolves, they are much more edgy. They raise their head much more often to look around while they're eating. They're usually aware of where wolves are more likely to be, and they oftentimes go to areas where they're less likely to be, versus naive elk that have grown up completely without wolves around, and they go anywhere they want. There's no real constraint. But of course, if you introduce wolves, a lot of bad things happen. In Yellowstone, this is exactly what happened when the population of bison and elk were naive animals when it came to being hunted by wolves. Now, they were familiar with grizzly bears and mountain lions, but wolves were a different matter. When wolves came in, there was heavy mortality right off the bat. But within a fairly short period of time, the elk actually learned about how wolves work. Obviously, there's strong selection there. So individuals who are a little more cautious probably survived better compared to individuals who were taking riskier behavior or were less aware of their surroundings. Now, in terms of biological predispositions, I didn't really cover this properly, but there were these studies by a guy named John Garcia, and here's a biological predisposition. Mammals have incredibly sophisticated taste receptors, and one of the predispositions, at least for mice, and for us too, is the sweet taste. We like sweet things. So they had water, in fact, that was sweet, and they used that as a stimulus, a conditioned stimulus, versus some other thing like, in this case, it might be light and sound. So they're not really as focused on light and sound as they are on taste. So there's a biological predisposition to focus on food and food. And a few other things I want to mention. Let's go back here. In terms of the sweet water and the fact that a lot of mammals can taste things, most birds actually don't have a very good sense of taste. In fact, a lot of birds, when they eat, they just grab something and swallow the whole thing. And so, let's say you have quail, and you give them something sweet. You can't. It does this controlled stimulus doesn't really work because it's not really part of their repertoire. Another example of a controlled stimulus that we already talked about earlier was the rhesus monkeys and the snakes. And if you remember correctly, we had in the wild, rhesus monkeys are very fearful of snakes. In fact, a lot of primates are. And there was a question, is this a learned response, or is this an innate response, or is it both? And some people argued for these different hypotheses. So with the rhesus monkeys, they bred some in the lab, and these were naive monkeys. Now, when you presented a naive monkey, plus there's this critical time period for monkeys in learning certain things, just like there is for baby humans, specifically, let's say, language, or for birds, learning song, things like that. So it's a critical period. We'll get into that later. But a young monkey, naive monkey, who's never seen a snake before is exposed to a snake. And the monkey actually doesn't really respond to it as, let's say, a dangerous animal. But if you put this naive monkey with other monkeys that know all about snakes, and the other monkeys see a snake, and they start screaming and chattering, like they're very, very attentive to the snake, then the young monkey actually learns that, oh, this is a dangerous thing. And then from then on, anytime they see a snake, they respond in kind. So it looks like, in fact, that monkeys learn to fear snakes. But the trick was, they set up a video system. And in the experimental design was that a monkey could watch a television. And these monkeys knew when they were watching, they were aware of what was going on. And in the foreground was an object. It could have been a snake, or it could have been a flower, or it could have been a piece of garden hose, whatever it was. And then in the background were a bunch of monkeys who were, in some cases, very agitated. So in other words, they see a snake up in front and they get crazy, and then the little monkey learns to be crazy too. Okay. Well, what they did though was, instead of having a snake in the front, they then substituted a flower. Now, if learning in this case was, if this was a learned behavior, then they should have learned to fear flowers as well. But the little monkeys didn't do that. They basically looked at the monkeys in the background and thought, these guys are crazy monkeys. What are they afraid of a flower for? So it appears there's a predisposition in monkeys towards fear for a snake. They did the same thing with a garden hose. Now, a garden hose isn't a snake, but it looks kind of like a snake. And little monkeys responded to that, not quite as strongly as a regular snake, but still fairly strongly. So there's part of an innate response there. In this case, it's predisposition. Even humans can develop, be classically conditioned in, let's say, for example, with nausea. We have a waiting room. We have an unconditioned stimulus, which is a drug. We have a conditioned stimulus, which is the waiting room. The response to the drug is actually nausea. And you can then get a conditioned response from from the conditioned stimulus of the waiting room. You can then get the conditioned response of nausea. So before they actually come in, well, before they actually get the drug, they come into the waiting room and they're immediately nauseous. Okay. So Pavlov's legacy, well, you can see, he kind of brought rigor, in fact, to the field in terms of psychology and behavior. It turns out before Freud, you probably heard of Sigmund Freud. Anybody who hasn't heard of Sigmund Freud? It's okay if you haven't. He started this idea of psychoanalysis. Subsequently, he's fallen out of favor. Everything that he assumed apparently has been pretty much wrong or incorrect. But before he started the psychoanalysis stuff, he was a behaviorist, and he was actually a pretty good one. Okay, so alcoholics, a drug that, let's say, affects the immune system response may cause the taste of the drug to invoke the immune system response. Okay, right. And then here's the Clockwork Orange that we just looked at. Watson used classical conditioning procedures to develop advertising campaigns. So this is all advertising. In fact, we're bombarded with advertising. If some commercials, they would show you actually a flash that was unconscious of some image. And then you find out, oh, later on you want to have this kind of food or whatever it is, or you want to go buy an Escalade because of this image. And they're trying to influence your behavior. So Maxwell House coffee, obviously. If you actually drank Maxwell House now, you'd have an unconditioned response of nausea, probably, because it's not very good coffee. Okay. Now, every time you take a shower, someone in your apartment flushes the toilet. So, as a result, you are sprayed with very hot water and you jump back to get away from the water. Now, every time you are in the shower and hear a toilet flush, you jump back before you feel the hot water. What is the unconditioned stimulus? Anybody? Okay. What's the unconditioned response? Okay. What's the conditioned stimulus? And the what's the conditioned response? Jumping away. Exactly. Okay, same sort of thing. The Office, Dwight and Altoid. So we could go to that, I guess. Let's see. Can I do that? Nah. Okay. So behaviorist John Watson. Psychology, as the behaviorist views it, is purely objective experimental branch of natural science. Its goal is to predict and control behavior. Introspection forms no essential part of its methods, nor is the scientific value of its data dependent on the readiness with which they lend themselves to interpretation in terms of consciousness. So, like we said, when we were out there and writing descriptions of what we were looking at in terms of the animals, we weren't really inferring what was going on in their heads. Inference in terms of that might be a hypothesis, but you can't make that inference just because of the behavior. So the behaviorist recognizes no dividing line between man and brute. The behavior of man, with all its refinement and complexity, forms only a part of the behaviorist tool scheme of investigation. And then give me a dozen healthy infants, well-formed, and my own specified world to bring them up in, and I guarantee to take any one of them at random and train them to become whatever I want. So, I guess it was a nice thought for some people, but apparently it doesn't work. As you all are examples, some people are good at certain things and not others, period. So there's, in fact, biological predispositions. Yeah.
I think I read something, that okay, this is gonna sound really racist. I'm gonna make it.
Okay, we're all gonna gang up on her after she says it. Okay. Okay, go on. Good.
For example, teachers think that Asian students are going to excel at math, and they treat them with already that they are good at it and pay them extra attention versus other students. Or other minorities and stuff like that, and because they're given that special attention, they kind of exceed to that expectation. I don't know what that is kind of called, but
well, no, I read the same article actually. Versus it's thought that women aren't as good at math as men. I know this isn't true because I know too many women who are excellent at math, and I'm a dummy. Now, this could be me, but I'm sure there's other people in here the same way. So, in the past, of course, teachers had this expectation about women and mathematics and science. You all, forget about the guys, all the women in here have disproved them wrong. But you might have, by a teacher that you had in the past, even unconsciously, been given the idea that, oh, women aren't good in math and sciences as guys are. Now, there's still lots of fields that are like that. You find very few women construction workers. I've met a few, though, that are really good. But also, you tend not to find a lot of women, let's say, in advanced physics, because it was thought that they didn't have the mathematical abilities, or in mathematics per se, period, that guys did. But we're finding out that's not true. There was a recent conference on black holes with Stephen Hawking, who came up with the idea of that things actually escape from black holes. In other words, information isn't completely lost. I'm not going to go into a big thing, but the woman who actually sponsored the conference has published something that actually mathematically shows that there really shouldn't even be black holes. Okay? Now, that doesn't seem to to actually be what's the case, because we've actually identified what appear to be black holes, especially large ones in the center of every galaxy. So, anyway. So this viewpoint has fallen obviously out of favor. But it was part of psychology for a long time. And it turns out humans have all sorts of predispositional biases that we unconsciously have. You know, I mean, no one could call me a racist. I hate everybody equally, right? So it's not like, oh, I hate black people. No, I also hate white people. I hate everybody. But it might be, of course, that in the past, since I was brought up at a certain time and place, that I had this bias about who could do certain things. If you ever catch me in this kind of thinking, then it's all right to jump up and beat me up. And that way there'll be a conditioned response eventually that will stop me from doing this kind of thing. You can use this against me, and I can obviously, I can do the same thing with you. You know, in terms of, I could perhaps make you nauseous every time you're about to take a test. And then leave the room, and everybody takes it, and it's a mess everywhere, and people don't do well. But, okay. I think that's it. Okay, that's it for now. There's no point in starting another lecture. So, are there any questions? I've given you instructions. Monday, a day of rest. A day of mirth. A day of good food and drinking, or whatever other drug that you might want to take. Okay? Now remember, certain drugs have stronger effects than others. You saw that picture of me, so you know. Sign up and start playing around with the behavioral ecology simulation. And then and then we'll meet again on Wednesday. So next week, obviously, we're not going out in the field. I'll be in the field, in the Sierras, but I don't know where you're going to be. Okay, see ya.